In this video, we're going to have a discussion about a metric micrometer. And up here is a very well-known individual, and he's going to keep me company in the making of this video. Now here's the metric micrometer and the various parts of the metric micrometer, as well as the imperial micrometer. They have names. The construction is the same for metric or imperial, only the graduations are different. But let's look at the names of the various parts. Here is a textbook, Dimensional Metrology. It's a very good book. In it, it has discussions about micrometers. And here are the various names of a micrometer. So we have the frame. Here's the anvil. There's the spindle, clamp ring, a barrel. Barrel is also sometimes called a sleeve. Here is the thimble. And at the other end is a ratchet stop. Let's have a closer look at the graduations here on the barrel. I have here a steel rule. Here we go. And the steel rule on one side is the imperial system in inches, 1 inch, 2 inch. Well, we're interested in metric right now, so flip this over. And on the top here, it's graduated in millimeters. And if I were to take those millimeters and divide them in half, that gives me the bottom scale right here in half millimeter increments. 0, 1/2, 1 millimeter, 1.5 millimeters, 2 millimeters. This graduation here in half millimeters is also reconstructed here on the barrel of a micrometer. I'm going to just hold this up a little bit, and maybe I'll just leave it there. I'm going to open this up so you can see all the graduations on the barrel, and it goes up to 25 millimeters. So that the range of this micrometer is 0 to 25 millimeters. And if I were to take this steel rule and overlay it on top of the graduations on the barrel in the half millimeter scale, you will notice that they will exactly line up. Here's the 0, and then there's the bottom is half millimeters, and the top is in whole millimeters. This exactly lines up. So it's 0, then half a millimeter, then 1 millimeter on the top, and then half a millimeter or 1.5 at the bottom, then 2. So this is, in fact, a steel rule right here on the barrel. So a micrometer is a steel rule with some attachments to it. And these attachments are here in order to do a little thing called amplification. What amplification allows us to do is to take something really, really small and allow us to see it. Much like magnification, which is done by lenses like this. Here it is on almost a 1-to-1 ratio. So if I want to look at it closer, I can magnify. The actual size doesn't change, but I can see a little closer to it. And amplification does the same thing, except mechanically. And that's what this micrometer is designed to do, give us amplification such that we can see or resolve with our eye something really, really small, which normally we could not see. And that's like this. Let me close this up a bit. Now, amplification, that's the that would be a topic for another video. Nevertheless, let's have a look at those scales right here. Excuse me. Let's take from 0 to 1. 1 millimeter, 0 to 1 millimeter, or I'll just use the ruler here. Here we go. Let's look at 1 millimeter. If I divide 1 millimeter into half millimeters, that's what this scale represents right here in half millimeters. Well, let's look at the 1 millimeter, 0 to 1. I'm going to redraw 0 to 1 millimeter here on my page and make it a little bit bigger so if we can all see it. So there's the 0 and 1 millimeter. 1 millimeter. I'm going to make it bigger so we can see it. Yeah, so like that. Let me just zoom in a little bit. And this is called magnification. So you can see the little lines here are a little better. And this is 0. And this one represents one millimeter. If I were to take this 0 to 1 millimeter and divide it into 10 even spaces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that'd be difficult to see with the naked eye, especially if I did it here on the steel rule, or if I did it there. Divide that into 10. Basically, you can't see it. So I'm going to amplify that over here. Here is my 0 line, and I'm going to divide 10. Put 10 across here. 2, 3, 4, 5, 6, 7, 8, 9, 10. And this will be my 1 millimeter line. So I've amplified it, made it bigger. So now I can resolve the individual lines. I can see them. And each one of these lines now represents, if they're from here to there is 1 millimeter, divided by 10 even spaces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's equal to 0.1 millimeters. Therefore, every one of these lines now represents 0.1 millimeters. From 0 to there, that is 0.1 millimeters. So I've taken that, expanded it. So from here to there is 0.1 millimeters. Let's take this now, this segment, and divide it into 10 even spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that's really, really fine. And again, let's amplify that here. So here's my 0 line. And the 0.1 will be over here. So I'm going to divide that into 10 yet again. 1, 2, 3, 4, 5, 6, 7, 9, and 10. That line here will represent the 0.1. Down here, that would be 0.1 millimeters. So I've taken that little segment and blown it up, so you can see it here, into 10 segments. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now each one of these segments now represents 0.1 millimeters. That's the distance, 0.1, divided by 10 even segments. Each one of these lines now represents 0.01 millimeters. That's 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.08, 0.09, 0.8, 0.9, 0.1. Take this again and divide that into 10 even spaces yet again between the 0 and the 0.1. That'll be 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And that distance here, amplified, is 0.01, from 0 to 0.01. Now each one of these lines represents, on this paper, 0.01, and divide that by 10 even spaces. 0.001 millimeters. And that's basically the idea behind amplification of this micrometer. So let's have a look. On the barrel, or sometimes called the sleeve right here, is the actual rule itself in increments of 0.5 millimeters, 0.5, 1 millimeter, 1.5, 2 millimeters, 3, 2.5, 3 millimeters, 3.5, 4, 4.5, 5 millimeters. And you'll notice on the barrel, numbers are written in terms of millimeters. There's 5 millimeters, 10 millimeters, 15 millimeters, and that's the same as the rule, except the rule actually has the 10. It actually has 10, 20, 30. And here it's in increments of 5, 5, 10, 15, 20, 25 millimeters. And at the bottom is the half millimeter. And here on the thimble, the graduations on the thimble are in increments of 0.01 millimeters. So each one of these graduations is 0.01 millimeters. So it's starting at 0, that first line, and here's the center line, that long line down the middle. So I line up that first line with the center line. That would represent a movement of the spindle here of 0.01 millimeters. So that's 0.01, 0.02, 0.03, 0.04, 0.05. Even though it's written as 5, that is in fact, I'll do it over here. That 5 is in fact 0.05 millimeters. And this is a manufacturing thing, okay? They just didn't put it in. So if I continue, that's 0.05, and each one of these has increments of 0.01, 0.05, 0.06, 0.07, 0.08, 0.09, 0.1 millimeters. That 10 represents 0.1 millimeters, and that is this part here. That 10 represents 0.1. So imagine this steel, the edge of the thimble. Here's the thimble, here's the edge right here. Imagine an imaginary decimal point here. So each one of these here are the decimal sections, are in decimals. So 0.10, 0.11, 0.12, 0.13, 0.14, and then 0.15. So these are in 0.01 increments. And thanks to a guy by the name of Pierre Vernier, and he come up with a vernier scale. That vernier scale is here on this particular micrometer. Some micrometers don't have this vernier scale, others do, this one does. And what that does, what I have done here, it divides this segment 0.01 into another 10 spaces. However, on this particular micrometer, they didn't go to this extreme of dividing it into 10. They divided it into 5. Take that 0.01 and divided it into 5 segments. So 0, 1, 2, 3, 4, 5 segments. So this would be 0.01. 1, 2, 3, 4. So if I take 0.01, divide that by 5, and that gives me increments of 0.002 millimeters. So each one of this is 2, 0.002, 004, 006, 008, and 0.01. This micrometer is designed using the vernier scale in increments of 2, 0.002. So it starts at 0, then the first line is 0.002, 0.004, 6, 8, all the way to 0, and that represents 0.01, or one of these increments. So I've taken this increment here, 0.01, between here, and divide that 5 times, and that is amplified here by using the method by Vernier, such that we can see something that small. So let's do an actual reading of this. And as I said, some calipers, or micrometers I should say, don't have this vernier scale. They only have readings or discrimination of 0.01 millimeters. But this one here does have it, so I'm going to go ahead and use it. To hold a micrometer, before you do a reading, you need to put your finger here, your pinky finger around the frame, and that leaves your index finger and your thumb free to move the thimble. I'm going to measure this steel block. I'm going to put it in here. And I'm not going to over tighten, just gently touch it. And then I'm going to use the ratchet stop. Lock it in place, such that the thimble here doesn't move. And we're going to do a reading. How wide is this block from the anvil to the spindle? How wide is that? Looking at the scale here on the barrel first, you want to read all of the increments on the barrel up to the edge of the thimble, right up to that steel edge. That's a decimal point. So all of the lines that are visible up to here, I have in millimeters going at the top. 0, 1 millimeter, 2, 3, 4, 5 millimeters, 6, 7, 8, 9. I see 9 millimeters. The line at 9 millimeters is visible prior to the thimble. Now at the 9.5, is it visible? Well, the answer is barely. Gonna have to go with the no. So I have 9 millimeters plus a little bit. That gap that you see here between the 9 and the edge, that's represented here on the thimble. This thimble, one full rotation of this thimble is 0.5 millimeter. So that little gap here is represented here. So now I'm going to read on the thimble to the center line. As I said earlier, each one of these has a decimal point in front of it. So let me write that down. I have 9 millimeters. That would be on the barrel. Now I'm going to read what's on the thimble. And everything on the thimble has decimal points to it. Let's do that over here. So that'd be 0.40, 0.40, 0.41, 0.42, 0.43, 0.44, that's 0.45. And the one that lines up to the center line is 0.45, 0.46, 0.47, and I'm reading 0.48. And it's almost exactly on 0.48. 0.48 millimeters, write that down. Then we can go to the vernier scale and see if there's any other line here that completely lines up. And the one that I see that lines up the most is the 0. So that'll be 0.48 exactly. On none of these other lines here, these are the 0.002 scale. They need to line up with the lines here on the thimble. And the one that lines up again is the 0. And these others don't line up. Well, that last scale is 0. So therefore, the thickness of that piece is 9.480 millimeters. We want to change this to centimeters. I'm going to do that up here. Changing that to centimeters, going to multiply by 1 centimeter is to 10 millimeters. Millimeters cancel out, so 9.480 divided by 10 is equal to, move the decimal place over 1, 0.9480 centimeters. Be sure to use the proper units. So it's just under 1 centimeter. And if we take this and use a rule, and you can see it's just about 1 centimeter. That 10 represents 10 millimeters, so just under 1 centimeter. There it is, 0.948. Let's do one more measurement. This time I have some steel balls. Let's see if I can get this. Yeah, that looks good. I'm right on the diameter of the ball. Now let's do this reading. Just want to turn the page over. Same as before, all of the increments on the barrel up to the edge of the thimble in millimeters. 1, 2, 3, 4, 5. There's 10 millimeters. And it looks like 11 millimeters is visible, that dark line on the top. So it's 11 millimeters plus 11.0 millimeters. That's 11 millimeters plus what's on the thimble. And the thimbles are all in decimal points, so here's the 0. Remember, these are increments of 0.01. This will be 0.05, and this is 0.1, and that first line is 0.11. But what I see here, the center line is between 0.1 and 0.11. So what I read on the barrel is, we're going to go round down, 0.10. And that little bit between the 0.10 and the 0.11, that is shown on the vernier scale, that extra little bit. So reading the vernier scale, I want to find out which one of these lines completely matches or lines up with the lines here on the thimble. This is the vernier scale. So looking at this, the one that completely lines up is this one here. And that looks like 6. Each one of these lines represents 0.002, 004, 006. And that's the one that lines up right here. So that last reading is 0.006. Add these up, and the diameter of this ball is 6, 0, 1, and that unit is in millimeters. Changing this to centimeters, take that and simply divide it by 10. That just moves the decimal place over 1. 1.1106, and the unit is in centimeters. And that is how you use a micrometer. And micrometer employs a concept called amplification, such that our eyes are able to see something as small as 0.00, in our case here, 2 millimeters.